Well, hi there, boys and girls. We're going to go over the integral of e to the u du. We're going to write down a few things that we know so far. What we know so far. Okay, so we know that the integral of du over u is the natural log of the absolute value of u plus c. We know that the derivative of e to the u is equal to e to the u times du dx. Well, this would mean also then that we should have an integral statement. So we're going to say this new thing. This is our video's topic for today. The integral of e to the u du is going to equal e to the u plus c. And again, it's going to be very important that that du is a perfect interderivative. So this is the majority of what we're doing today. So let's just get started. First example, I've got this integral, and there's an e in here, and there's an exponent, and then there's extra stuff. I'm curious if this extra stuff is a perfect interderivative. Well, if I let u equal 5x squared plus 2x minus 3, then du equals 10x plus 2 dx. I went ahead and cross-multiplied by the dx. And that's very nice and pretty. Looky there. Wow, that's exactly what it is. So we have the integral of e to the u du. Therefore, my answer is e to the u plus c. So this should be e to the 5x squared plus 2x minus 3 plus c. It's right there. That's not so bad. Let's take a look at another one. What about e to the 7x? Now, I really wish there would have been a 7 right here. So for those of you that are really good with this shortcut, you can just put a 7 right there. And then, of course, out here you'll have to put a 1/7. But for those of you that don't understand that, we're just going to go through u-substitution. We'll let u equal 7x because that's the exponent on the e. Du is equal to 7 dx. All I have to substitute for is the dx, so I'm going to solve this equation for dx. So 1/7 du is equal to dx. So this turns into the integral of e to the u times 1/7 du. And so my answer is 1/7 e to the u plus c. So where is that at? It looks like that is right here at c. Alright, what about a more difficult one? Well, here I've got a fraction, so you might want to think about, is it u prime over u? If you let u be this entire bottom, then there's no way the top is just u prime. So we're going to have to get creative here, and we're going to rewrite this as 1 over 1 minus 1 over e to the x dx. Of course, e to the negative x is 1 over e to the x. I'm going to then make common denominators, so that 1 will become e to the x over e to the x, and I'm going to subtract. So this is the integral of 1 over e to the x minus 1 over e to the x. And I have a complex fraction, so we know we can take this bottom number, flip it over, and multiply. So this will be the integral of e to the x over e to the x minus 1. Now, I did all of that algebra, and now I have a prettier integral because this is u prime over u. If we let u equal e to the x minus 1, then du is equal to e to the x dx. This is a pretty little du over u integral. So this answer is the natural log of the absolute value of the bottom plus c. And so that is why it is A. That was sort of tricky, but you're going to see stuff like that in your homework. So thank you, Mr. G. Yeah. All right. This one was easier. If I think about this as u prime over u, I'm not really happy that 5 is there, because if the bottom is u, then I just want e to the x on top. Well, of course, we know we have the right to pull out a constant out of anything, pretty much. Any integral, any derivative, any limit. And now I have u prime over u. So it's 5 times the natural log of the bottom. And e to the x plus 1 is never, ever negative. Therefore, the absolute value is not necessary there. So that's going to be D. Alrighty, let's see here. I think I've got one more. Yeah, this one's sort of messy, so buckle up, baby. Buckle up. I'm going to rewrite this as the integral of e to the negative 2 over x times x to the negative 2 dx. And I'm going to see if I can make this into an e to the u integral. So if that's the case, then my only choice for u is negative 2 over x. I'm going to go ahead and write that as negative 2x to the negative 1. So du dx would be 2 over x squared, or 2x to the negative 2. And I'm sort of liking that because I have an x to the negative 2 here. So we just need to solve this for x to the negative 2 dx. So I'll get 1/2 du equals x to the negative 2 dx. So that's not too horrible. This will be the integral of e to the u times 1/2 du. So this is 1/2 e to the, my u is negative 2x to the negative 1. I'll just call that negative 2 over x plus c. So let's see if we can find that in here. It looks like that one is D. That wasn't too easy, but still with u-substitution I was able to make that happen. Hey, I'm excited about tomorrow. Tomorrow's our Thanksgiving with our family at school. We're going to be eating together and doing some math. Math with Mr. G, food, waffles. I bet you've never had it better than that. Deuces.